All right, and welcome back. So let's start out with a quick do now. We're going to do the following for the next 6 problems. We're going to write the fraction in simplest form. Do not change improper fractions to mixed numbers. We're going to leave them the way they are, but we want to simplify into simplest form. Remember, that means that we are simplifying both the numerator and the denominator by the same factor. We're going to be dividing the top and the bottom by the same number. So please try out these 6 and resume when you are ready to check your answers. All right, so if you listen to my voice, that means that you have attempted these 6 situations and you're ready to check your answer. Well, if we have 24 over 48, we can divide both by 24 and we get 1 over 2. You might have divided it by 4 and then by 4 more, or something along those lines. You might have divided by 2 and then 4, or 8 and then 3. You might have done some kind of manipulation like that, and that's totally fine. But you should get your final answer as 1 over 2. All right, if we're talking about 64 over 48, this one's a little bit tougher for me to do initially, so I'm going to pull out a factor of 8. 64 divided by 8 is 8. 48 divided by 8 is 6. Now this is a lot easier for us to do. We can divide by 2. Look at that. I'm a poet and you didn't even know it. It's a lot easier to do. Now we can divide by 2. Woohoo! Skip to my loo. Here we go. Number 3, we have 30 over 24. We could go off by 2 and just keep on going with that. But we want to see what is the biggest number that we can simplify with. And that's going to be 6. We can simplify by 6. 30 divided by 6 is 5. 24 divided by 6 is 4. All right, here we go. 9 over 21. We can simplify both by 3, and we get 3 over 7. All right, we are almost there. 45 and 63. This one's a toughie. Let's see what happens if we divide by 9. See, 45 divided by 9 is 5. 63 divided by 9 is 7. And lastly, we have 10 and 41. I'm trying to think, are there any factors that we can divide 10 and 41 by except for 1? Nope, that's it. We can only keep it as 10 over 41 because that's a simplified form. We cannot divide 41. 41 is a prime number. The only factors of 41 are 1 and 41. Awesome. Now that this has jogged your memory, let's start to talk about relationships here. Ooh, relationships. So we're going to be comparing the following relationships. We are going to be asking ourselves, is each relationship fair? If they are equal, then the answer is it is fair. They are not equal, then the answer is it's not fair. And please be ready to explain your reasoning. So we're going to go through each 3 scenarios. At the end, I'm going to ask which one of these is fair and how do you know? So for A, you pay $184 for 2 tickets to a concert, and I pay $266 for 3 tickets to the same concert. Is A fair? B, you get 75 points for answering 15 questions correctly. I get 70 points for answering 14 questions correctly. Is B fair? C, you trade 24 football cards for 15 baseball cards, and I trade 20 football cards for 32 baseball cards. Which one of these is fair? Is there more than one? And why would they not be fair? Please answer below. Hopefully, you should have answered that B is the only fair situation. And we can, relate this to your quizzes or assessments that you have. If you get 75 points for answering 15 questions correctly, that means that each point is worth 5, or each question, is worth 5 points. Let's compare that to my score. I got 70 points for answering 14 questions correctly. 70 divided by 14 is 5. So we each got 5 points for one question. The relationship is the same. The numbers were different, but the overall relationship was the exact same. For A and C, we don't have the same relationship. If we look at A, you pay $184 for 2 tickets. Well, how much is it per ticket then? It's going to be $92 for you for 1 ticket. But if I pay $266 for 3 tickets, I pay about $89. So we're not paying the same amount per ticket. So that relationship was not fair. And for C, you traded 24 football cards for 15 baseball cards. I traded 20 football cards for 32 baseball cards. So if we just look at the starting and the ending point, you started with more football cards and you had less baseball cards at the end. I started with less football cards, and I got more baseball cards at the end. So that is not a fair relationship. We did not have the same overall trade. And this leads us into what we call proportions, and this should ring a bell. So the key idea here, and please copy this down in words, a proportion is an equation stating that 2 ratios are equivalent. They're the same. 2 quantities that form a proportion are called proportional. So we're just changing proportion and we're throwing AL at the end, the proportional. So if we had 2 over 3 is equal to 4 over 6, then you would say it as 2 is to 3 as 4 is to 6. And you might have heard this from a while ago, but in more real life scenarios. So for example, if we have 2 apples and 3 oranges, well, that's the same ratio. That's proportional to 4 apples and 6 oranges. How did we get from 2 to 4 and 3 to 6? We multiplied by 2. So the overall value is still the same. Well, that's also the same as 6 apples to 9 oranges. To get from 2 to 6, we multiplied by 3. From 3 to 9, we multiplied by 3. So the overall value is going to be the same. The relationship is still going to be the same. If I were to draw this for you, 1, 2, 3, 4, 5, 6 apples, and I unfortunately don't have orange, so I'm just going to have to use purple. Why not? 1, 2, 3, 4, 5, 6, 7, 8, 9. I can group these from a ratio of 2 to 3. I can separate my apples into groups of 2 and my oranges into groups of 3. Notice I have 3 groups of apples that have 2 of them in each, and I have 3 groups of oranges that have 3 in each. So we have the same amount of groups. We just broke it up in the equivalent relationship, the equivalent ratio, right? So hopefully you've heard about these proportions before. All it is we're saying, hey, is this fraction equivalent to this fraction? Do they have the same overall value? Which is why we were simplifying those fractions in the beginning. We were simplifying to see, okay, once I reduce everything, will we have the same overall value? And that is what we're going to do now. We are going to tell whether or not 6 over 4 and 8 over 12 form a proportion. So without further ado, let's look at 6 over 4. What can we simplify 6 over 4 to be? Well, 6 over 4, we can divide both the top and the bottom by 2, and we end up with 3 over 2. So 6 over 4 turns into 3 over 2. So if I wanted to form a proportional relationship, that would mean 8 over 12, when I simplify that, turns into 3 over 2. So let's try that out. If we have 8 over 12, we want to think of how can we simplify this? Well, we can divide both the top and the bottom, the numerator and the denominator, by 4, and we get 2 over 3. So now we have to ask ourselves, is 3 over 2 equal to 2 over 3? No, it's not equal. They're the same numbers, but they're in different locations. These fractions are not equivalent. If you were to type it into a calculator, 3 over 2 would give you 1.5. 2 over 3 would give you 0.6666 repeating. Those are not the same decimals. They're not the same fractions, which means they do not form a proportional relationship. So our final answer would be no. 6 over 4 and 8 over 12 are not proportional. Sad face, because we want it to be proportional. Since we could not simplify both fractions to get the same overall value, they're not going to be proportional. All right, with this, I'm going to ask that you try out 1, 2, 3, and 4, and we're going to come back and talk about 5. So you please try out 1, 2, 3, and 4. Tell whether the ratios form a proportion. Are those ratios proportional? Can you simplify to the same fraction? Remember, we want to simplify to the same fraction. All right, so without further ado, try it out and resume when you're ready to listen to my voice. All right, if you listen to my voice, I mean you've tried out 1, 2, 3, and 4, and we are going to do 5 together. So 1, 2, 3, and 4. Let's see, can we simplify both fractions to be the same? Well, 5 over 10 can turn into 1 over 2. Is 1 over 2 the same as 1 over 2? Yes, it is. Yes, it is. Let's go to number 2, 4 over 6 and 18 over 24. I can reduce 4 over 6 by 2, and I get 2 over 3. I can reduce 18 over 24 by 6. I get 3 over 4. Is 2 over 3 the same as 3 over 4? No. So the second relationship is not proportional. All right, let's go on. We have 10 over 3 and 5 over 6. Let's see if we can simplify 10 over 3. I don't think we can. 3 is prime, so we can't divide anything except by 3, but we can't divide 10 by 3. So that stays as 10 over 3. What about 5 over 6? No, we can't simplify 5 over 6 either. 5 is prime, and 6 cannot be divided by 5, which means that 3 is not going to be proportional. 10 over 3 is not proportional with 5 over 6. Lastly, number 4, 25 over 20 and 15 over 12. Let's see if we can simplify those fractions. 25 and 20 can be divided by 5, so we get 5 over 4. Likewise, 15 over 12 can be simplified by 3. 15 divided by 3 is 5. 12 divided by 3 is 4. So yes, 25 over 20 is proportional with 15 over 12, because when we simplify, we get the same fraction. Awesome. Let's talk about number 5. So we want to tell whether or not x and y are proportional. So we have all these x values, we have all these y values. So we are talking about building some birdhouses, and we need to use a set number of nails. So what we can do is we can tell whether or not by looking at a fraction. Let's relate this back to slope. Slope, we always had the y value over the x value. So let's just continue the same thing. You need 12 nails to build one birdhouse. So if we write that as a fraction, we'd have 12 over 1. We have our nails over our houses. Remember, it's our y value over the x value, just like it was for slope. It was the change in y divided by the change in x. So we have 12 nails for one house. We have 24 nails for 2 houses, 48 nails for 4 houses, and 72 nails for 6 houses. Now we want to figure out, can we simplify to get the same fraction, the same value? Well, 12 divided by 1, is 12. 24 divided by 2 is 12. 48 divided by 4 is 12. I'm running out of colors. No. Let's go gold. And 72 divided by 6 is 12. So we get the same overall value. We use 12 nails for every one birdhouse. So that's our proportional relationship. We use 12 nails for each birdhouse. So this is going to be the answer here. We figured out that X and Y are proportional. The number of houses built compared to the number of nails used, or the number of nails used compared to the number of houses built, is the same. We use 12 nails for each birdhouse. We use 24 nails for 2 houses, 48 nails for 4 houses. So if we break it down to figure out how many it is for one birdhouse, we use 12 nails each time in each scenario. Awesome. And last but not least, let's talk about a word problem here. It says that you read the first 20 pages of a book in 25 minutes. You then read 36 pages in 45 minutes. Is the number of pages read proportional to your time? So let's set up some fractions. Let's set up some relationships, some ratios. Let's see if we can figure this out. So the first thing that I see is I have pages and I have minutes. So I'm going to create a fraction, a ratio, that compares number of pages to the number of minutes. So my pages will be in the numerator. The number of minutes will be in the denominator. Well, let's see if we can fill in some information. I'm given that you first read 20 pages in 25 minutes. So I'm going to replace pages as the numerator with 20, because I read 20 pages, and minutes as 25, because I took 25 minutes to read it. Then says you read 36 pages in 45 minutes. So 36 will go in the numerator, that represents the number of pages, and 45 in the denominator, that represents the number of minutes that it took. We want to see, is it proportional? Are these two proportional? In order for us to do that, we have to simplify and see if we get the same overall fraction, the same overall value. Well, we can simplify 20 and 25 by 5. So we get 4 over 5. And that should be equal. What can I simplify 36 and 45 by? I can pull out 9. 36 divided by 9 is 4. 45 divided by 9 is 5. So we do get a proportional relationship. And if we wanted to put it into words, well, we can use that by going back to our given. The fractions represent the number of pages for the number of minutes that I read. So if I ended up with 4 over 5, that really means I read 4 pages for every 5 minutes. And soon we're going to be able to use this relationship or these proportional relationships to figure out new values. But again, we started by creating a relationship of the number of pages compared to the number of minutes that I read. We filled in 20 pages for 25 minutes and then 36 pages for 45 minutes. We simplified down to see if we can get the same overall value, and we got the fraction of 4 over 5, which means in words, I read 4 pages for every 5 minutes. And that's how we go talk about these proportional relationships. So your job today is going to be to figure out whether or not relationships are proportional. You're doing a great job with this, folks. If you have any questions, please let me know. Keep up the good work, and I will talk to you soon.